JavaScript. Introduction to Functional Programming. JavaScript is a functional programming language. We will discuss code placement options, callback functions, closures, and performance analysis techniques that relate to functional programming in JavaScript. I recommend the book Secrets of the JavaScript Ninja by John Resig and Bear Bibbo. Section 1. JavaScript Code Placement Options. JavaScript code, such as event handler functions and any other useful functions, can be placed in three distinct locations. These are external JavaScript files, script tag content, and inline JavaScript. In this demonstration, we're going to take a look at the options that are available for placing JavaScript code within HTML markup. And so I've created a folder here called JavaScript Placement Options. If we open that up, we see that we have a .js file and an HTML file. So the .js file is an external JavaScript file, and that's one of several locations where we can place JavaScript code. Let's open that up in an editor, and we don't really need a fancy programming editor for this. It's sufficient just to use Notepad. We're not going to actually write code. We're just going to review existing code and discuss how it works. But as you can see here in this file, this is named external JavaScript.js. We define a function called external function. And so it takes three parameters and it has three statements in its block of code. So element ID, text, and color are being used in this code. First of all, the first parameter is used to access a particular element by ID, and that gives us the element. And we're going to see that this is actually going to refer to a P element, a paragraph within this page. And then the second parameter is assigned to inner HTML of that element, modifying the text displayed within that P element. And then the color is being assigned to change the color of the text in that element. And we're using a CSS style named color to do that. So that's basically a simple function. It's called external function. And I just named it that to indicate that it is a function that's defined in an external JavaScript file. Of course, we could have called this anything we wanted, but I'm going to have three different versions of this function that are all identical except that they have different names. And that's just to keep straight when we're looking at this, where these functions are being called from, it'll become clear which one we're calling. So this one is the one that's defined in the external JavaScript source code file. So if we take a look at so let's take a look at this HTML file. We'll open that up in Notepad as well. And you'll see here that we have, in the head element, we have two script tags. There's the first one, there's the second one. Now this second one is actually what's making a reference to this external JS file. So that's the same as that, external JavaScript.js. And so that script brings in, this script tag here brings in that external JavaScript file. So that, together with this script tag, which has embedded within it a function that's also, it's exactly the same function. If you take a look at these two functions, they're identical. So this is a function, that's a function, this takes three parameters, that takes three parameters, this has three statements, this has three statements. It's exactly the same. The only difference is that this is called external function and this is called head function, because that's defined in an external JavaScript file, and this one is defined within the head element. So now we've seen two out of several possible locations for JavaScript code. These are in the head element. There's a script tag containing JavaScript or an external script, like so. So by the time we reach the end of that head element, we now have two functions available so that we can call into these two functions, one called external function, the other one called head function. Okay, so then we take a look down here and we see a P element, and it contains the text. This text will never be seen. We're declaratively defining it within the markup here. However, if there was never any JavaScript code to be executed, then that's what we would see in the page, in that paragraph. But this is not what we see. We'll see that it's actually been replaced in numerous ways by JavaScript code that executes within this page. But let's take a look at what this looks like in a browser. So let's open this up in, let's say, Google Chrome. And so there's a couple of alert message boxes that come up. We'll see the code that does this later. It's towards the bottom of the page. Let's not go into detail on it just yet, but this is an alert message box that says this code runs as the page is loading. And then afterwards we get this alert message box that says this code runs after the page has already loaded. And so we'll see at the bottom of the page where we've got two script tags, one that executes in line within the page as the page gets loaded and parsed and rendered. It gets executed right off the bat as that happens. But there's another alert message box and another JavaScript that gets that's associated with an event. This is the page load event. And so when it gets loaded, then it will call that event handler JavaScript code, and that happens later. So anyways, more on that in just a bit, but let's dismiss that. Let's click on OK. And we see here that this paragraph here has been modified. So what was originally this text here, it's been modified, and we haven't even done anything. We haven't clicked on any of these buttons yet, but there is some JavaScript that has already executed, and so it says here JavaScript runs as page loads. Well, are we sure that that's the paragraph element? We can always verify that, right? Let's right mouse click on here and view page source, and sure enough, here is the paragraph element. And you'll notice that when you view source, what you see is the original text as it was declaratively defined. This is not a live update of what is actually happening in the page dynamically after it's loaded and running, and then JavaScript may make changes to these types of things. But that is the paragraph element that we're seeing right here. Okay, so what happens if we click on these various buttons? So we can we see here that there's one which calls inline JavaScript. That displays it as red. Click here and it calls JavaScript function in the head element. Well, that's the one we were just looking at, by the way. That is that's this one here, head element function. There's this one here which is called JavaScript in the body element, and that makes it blue. We haven't seen that yet, but if you go a little further down, we do see a script here which is called body function. So if you look carefully again, that's also exactly the same as what we had before. So this is a third version of this function. The only difference is that this one is now called body function because it's defined within the body element within this page, but it has the same three parameters and the same three statements that do the same thing. Okay, so and then so that's the blue one, and then there's also call JavaScript function in an external file, which is the one that we saw before, and that turns out to be magenta. Okay, so we've pretty much covered everything. Let's just do a quick review, recap, and just to clarify where these different locations crop up within this code. So again, we have this is a script that's defined within the head that contains a function. This is a script that refers to an external JavaScript within the head, but we can also put it in the body, as we'll see further down. I should just quickly mention that a lot of people like to put JavaScript in the head, and that's probably usually okay, but be careful when you're bringing in an external JavaScript file. Some people will bring in very large JavaScript files like jQuery or Ember or Backbone or Bootstrap or any of these Angular or whatever. Some of those JavaScript files are pretty big, and so this basically starts processing. The browser goes through this top to bottom, and if it hits something that takes a while to do, then it's kind of blocked there for a bit, and then when it's done loading and parsing the JavaScript, then it moves on and it continues to display the rest of the page. So that can cause a little bit of a delay, and it might be a little bit annoying because you'll just basically be looking at a blank page for a moment before it actually comes back to life and displays the page properly. So some people like to put that kind of thing at the very bottom right before that closing body element of the body tag. Okay, so moving on, we have a button here and on click, and then we have a button here and then on click, and then we have a button here and then on click. So we've got three buttons. When we ran it, we noticed that there was actually four of them, right? But let's take a look at these three. So this one has a click event handler that's wired up to execute this JavaScript code. And so what I've just highlighted with my mouse here is three semicolon separated JavaScript statements. And if you look closely, this is actually the same code that we saw in the three functions that we've seen. It's just that in this case, it's actually JavaScript that's embedded in line within an actual element. So there's yet another option that we have for locating JavaScript code. But so we declare a variable, and we get element by ID. Then we take that element and we set the inner HTML, and the color is red, right? So that's why when we click on here, it goes red. That's in line. The next one here is calling the head function, and here we're calling the body function. We saw the head function was defined in a script in the head element, and that was green, right? So that's what this one is. That's the green one, and that is calling into this function, the head function in the head element. And then back to where are we here? So then so that's the head function, and then there's the body function, which is declared a little bit further down. So this is the body function that we're calling here, and this one is the one that's going to show as blue. So there's the blue one. And then we have the last button on the far right, which is calling into that external function that we saw earlier, and that's the one that shows up as magenta, which is this one here. So we've basically finished talking about all the buttons and all the scripts that get located in various places to implement functions that we can call from various locations. The last two little bits here are these two script tags here, and these are the ones that, well, first of all, this one here is executed directly in line. It's not the result of an event. It's not the result of some code calling into it. It's not a function. It really is just a raw statement of JavaScript that's embedded in the page, and as the page loads and executes, it happens actually as the page loads. And that's why I'm saying here that this JavaScript runs as the page loads. It's kind of automatic, just as an effect. It's basically an effect that's a direct result of the page getting loaded by the browser. Nothing special. But down here we have a script that has two things going on. First of all, we have the window.onLoad event, and we're wiring that up as a handler. So we have a function here, and by the way, this function has no name, so this is what we would refer to as an anonymous function. But basically that code executes this block here where we have an alert message, and it says this code runs after the page has already loaded. So that comes later, and this one here is immediate. So we get this alert displaying the text, this code runs as the page is loading. So notice that that's ed past tense and that's ing as it's happening. And I put them in this order intentionally because I don't know if you recall, but when we ran this, this is the one that we saw first, and this is the one that we actually saw happen second. And that might be surprising because this one appears earlier in the page. Wouldn't you expect that one to get executed first and then this one gets executed? Well, in fact, really, if you think about it, this one does actually execute first, but what we mean by execute means that we're doing an assignment to this event handler. It is only when that event actually occurs later that that event handler is called back into, and that does happen after the page is completely loaded, which actually happens after this second alert already finishes whatever it was doing. And once the page is fully loaded, then the onload event is fired, and then our function puts up this second alert message box. So I just want you to be aware that events, whether you're talking about onload or any of on click events, when the event happens, that's actually going to determine the timing of when this particular piece of code actually executes. But if I do a refresh, there you go. You see the code runs as page is loading and then loaded. And you see that here, the second one here, loading and loaded. So basically that's all I have to say for this demo. Hopefully now it's clear that you can define JavaScript in a number of different places, externally or within the head or within the body, or as event handlers, or just in line within the page. Section 2, JavaScript Callback Functions. JavaScript supports a function-oriented style of programming which treats functions as first-class objects. This makes it possible to use callback functions in clever ways. Callback functions are used in many situations, including useful techniques such as various event handling patterns. We'll talk about function-oriented programming, functions as first-class objects, callback functions, and the function invocation operator. This sample program is titled A Simple Callback Example. And it is very simple, but it's very important to understand this example before going forward. Basically what we're going to talk about here is using functions in JavaScript. And JavaScript is fundamentally a function-oriented programming language. And so we'll talk about this example, but as I say, it's very important to understand this going forward because pretty much everything we do in advanced JavaScript programming is dependent on a good understanding of what functions are and the idea that JavaScript is a function-oriented language, which really just means that functions are first-class objects within the language. And so anything that you could do with any other kind of object of any other data type, those same things can be done with a function as an object. So a function is just an object that happens to be invocable or callable. And so anything that you can do with a regular object, such as assign it as a property on some other object, or add properties to it, or assign to a variable, or pass in as a parameter, all of these things are possible with functions, just as with any other object. Now a little background just to highlight the importance of functions in JavaScript. It turns out that back in 1995, when Brendan Eich first created JavaScript, he used as inspiration a number of languages that existed at that time. Probably the two most important influences on JavaScript were the languages named Scheme and Self. And so Scheme was the idea of function-oriented programming, and Self introduced the concept of prototype-based inheritance. And probably function-orientedness and prototype-based inheritance, those are the two most fundamental and most important ingredients in JavaScript. So this is actually very important to understand. Okay, so in this code example, we're going to be taking a look at a callback function. And that's the idea that you can define a function and then pass that function in as a parameter to some other function. And on the receiving end within that called function, it's going to receive that parameter, which is a function, and it's going to call back into it. And that's why it's referred to as a callback function. So this is fairly short and simple. It should be fairly easy to understand. It's just this script tag here. That's it. And as a side note, there's also assert.js, which we probably don't care so much about. The details are probably not that important. But as you can see, there's the assert function here, and there's the report function here. And we're going to use both the assert and the report function. There's also pass and fail, which are used internally here. But rather than going through the details of how this works, especially the assert function, it's not that hard, but obviously it's interacting with the user interface and updating the user interface. Maybe what we should do is just try running this to see what this looks like. So let's run this in a browser. And as you can see, there are 6 text messages being displayed here. And so there are 5 calls to report. There's 1, 2, 3, 4, 5, and there are 6 messages out here. So one of those is actually coming from this assert. And I'll talk about a bit about what's going on there in just a moment. But as you can see, this assert here, we're testing for equality. So if I were to, for example, just change that to a not equals and save that to update that, we see here that it changes the output. So it becomes red with a strike through. So green is good and red is bad, basically. Well, I should say green indicates the assert succeeded and red indicates that the assert failed. Okay, so let's take a look at what's going on in the code here. We have a global variable named text defined within our script, and we initialize it with this literal string expression, domo arigato, and then we indicate that we want to display that. So it's going to say before defining functions. Actually, let's run that again just so we have that handy to look at. Okay, so, and actually I should probably put this back to equality rather than inequality. So this report here, before defining functions, that's this one here. And then we define two functions. Now they both have report being called within them, but they don't produce any output, at least not yet, because this is purely declarative. It's setting these functions up. It's defining two functions that are named useless and getText. But the code in those functions don't get executed until those functions are explicitly called. So this code is executed directly as it loads the script into the page, but these are set aside as a declarative definition for functions that can be called at a later time. So this is kind of an odd name for a function, useless, and I suppose that it's given that name just because it doesn't really do anything really useful. It's really just here for demonstration purposes. So obviously this is a contrived example to demonstrate in as simple as possible an example of how you can pass in a function and call back into it. In any case, a useless does take a parameter called Ninja callback, and getText doesn't take any parameters. It just does a report to produce some output on the page. And so notice that useless, it returns the result of calling this callback. So that's interesting. The parentheses here indicate that we're passing in this parameter, which happens to be a function object. That function object is being invoked with these open-close parentheses. That's actually an operator. It's an operator that invokes a function by way of a variable that refers to a function object. And that's what was passed in as a parameter. So what's being passed in as a parameter? Well, we'll see that actually this other function named getText is what's being passed in. But that happens down here. So first of all, we see a report before making all the calls, which is this second message up here. And then we say assert, and that the parameter to assert is, well, there's two parameters. I think you might have noticed when we looked at this. The first parameter is basically used as a Boolean expression. JavaScript has this concept of truthy and falsy values, which is slightly more general than the Boolean type, but it's either going to be a Boolean type or it's going to be a truthy or a falsy value. But that gets evaluated. And so this is actually a call to useless here. And so what happens here is this getText is referring to this function here, and that is what is being passed into the call. We're calling useless, and we're passing that in as a parameter, and then we're calling back into it. So this call here will actually call what this refers to, which is actually the name of this function. So getText is actually an identifier. It's basically declaring an identifier of type function that refers to the function that's implemented in this code here. And so, as I said, this calls back into it, which is where this report takes place here. And if we see where that shows up, this in getText function is right there. This report here, which is in the useless function, is this one here. And so you can see the order in which they occur. We call into the useless function, and then the useless function calls back into the getText function, because that's what was passed in as that parameter right here. So anyways, we're testing for equality to see if what got returned, which is this guy here, and of course that's referring to that variable there, so of course that does equal. It's returning exactly that, and so that becomes true, and therefore we see the useless function works, which is what we see here. And then after it's all said and done, then we get this final output here. And so as you can see in this example, we have a callback function that demonstrates one of the aspects of how a function-oriented language like JavaScript works, where functions are just first-class objects within the language. Section 3. JavaScript Closures. JavaScript supports closures. Closures are a useful way of solving important programming problems that relate to variable scope, and they make it possible to implement object-oriented programming patterns in JavaScript code. We'll take a look at the scope problem that closures solve, nested functions and outer local variables, how closures work, and then we'll take a look at closures and object-oriented programming techniques. We're now going to talk about two code examples, and the first is titled A Simple Closure, and the second one is titled A Not So Simple Closure. Well, the not so simple closure is a little bit more complicated than the simple one, of course, but in real life you're probably going to run into closure scenarios that are much more complicated than either of these. But these both provide a nice entry point into understanding the concepts of closures, and I think that once you understand these code examples, you'll probably be in good shape for understanding more complicated scenarios that involve closures. But before we talk about what a closure is, we should probably talk about the problem that closures solve. And in order to understand that problem, we have to consider what the choices are that JavaScript provides in terms of the scope of visibility for variables that are declared as global variables and local variables. So these are the only two choices that we have, and they're extreme opposites. In the case of a global variable, this is really just a variable that's declared outside of any function. So this variable named outer value would be an example of a global variable. And these are also global variables in this other code example here, outer value and later. But within this function named outer function, we have a local variable declared within that function called inner value. Now, the fact is that global variables are visible everywhere throughout your application, whereas local variables are only visible within the function that they're declared in. So that's called function scope. And so there's a problem being limited to these two extremes, and I'll explain that. So with global variables, in a simple little example like this, it's probably not a big deal because you can pretty much see everything that's going on and you're in control of it. But in a very large application that involves multiple JavaScript files, many of which might have thousands of lines of code in them, perhaps written by multiple programmers that don't necessarily communicate closely with one another, how is that going to work where you have global variables where identifiers are dreamt up by programmers and they could potentially just randomly named variables could end up colliding with one another? So if you're trying to bring in two JavaScript libraries and use them both in the same application, one library could define a global variable and another library could define a global variable that just accidentally had the same name, and then they would be in conflict with one another. One of those would try to be doing something with a variable that was at odds with what some other JavaScript code was trying to do with that same global variable. So the problem that we're talking about here is pollution of the global namespace, and a good guideline is to always try to avoid defining global variables to reduce that possibility of collisions of names within that namespace. Okay, so we could say we'll just really try to avoid global variables, and that's a good plan. But the problem is that the only other alternative we have is a local variable within a function. Now, I'm not going to go into super detail on this. You might want to double check, just if you want to search on the topic of hoisting, you will find that JavaScript basically has function scope but not block scope. So it's a little bit more limited than some other languages like, for example, C# and Java and C++ and so on. But so every variable declared anywhere within a function is essentially hoisted to the top of that function and is visible throughout that function. Now, the point here is that the local variable within a function is only visible to code within that function during the time that the function is actually executing. So if you execute some code and then you call into a function and then that function executes and then you return from that function and then you continue on and execute subsequent code after that function call, well, the only time during that whole sequence that the local variable is actually accessible to your code is in the function call. It doesn't exist before the call and it doesn't exist after that call returns. It's only limited to the code within that actual function call. So it's basically temporarily created. This is why the local variables are often referred to as temporary variables. They're allocated on a stack frame on the stack as the thread of execution calls into that function and then returns from it. So they're limited in lifespan and they're limited in scope. Opposite of globals. Globals are from the time they come into existence to the end of the program, essentially, they continue to exist. So they have a long lifespan and they're visible everywhere, so they have a very broad scope of visibility. Local variables within functions are the opposite. They only exist during the execution of the function, and they cease to be accessible anywhere outside of that function. So you might think, oh, that's fine. Just work with the functions and use them as local variables. And that's exactly the approach that's taken by many people. Quite a lot of people are proponents of so-called functional programming techniques. And JavaScript is a functional language, so it's fully capable of doing that kind of programming. But some people like to use JavaScript in more of an object-oriented approach. It's kind of a traditional approach that many people are familiar with coming from a background such as C++ or C# or Java. And so to accommodate that traditional object-oriented style of programming within JavaScript, that's where we want to take advantage of this thing called closure. So it's a little bit of a tricky concept. Let's go back to this first code example here. We have this global variable out here, then we have a function, and then we call that function. And that function executes, and it appears that this function refers to this global variable outside of it. Now, it is true that a closure usually involves, or I should say it always involves, code in a function that refers to variables defined outside of that function. However, I would argue in this particular example, this outer value is not really a closure. It actually is a global, which is by default visible anyways. So there's not really anything special happening here. There's no closure actually taking place in this example because we're dealing with a global. So there's not a whole lot more to say about this code example. Let's move on to this second part, which is actually a more realistic example of a closure. And so here we have the global variables named outer value and later. These are both used for very different purposes. But in any case, within this script we have this function being defined. It's a function named outer function, and it has nested within it the declaration of an inner function named inner function. Now this is typical of closures. You almost always have a situation where you define an outer function and it defines a nested inner function, and typically it will return that inner function, or it will assign that inner function to a global variable to make it accessible outside of the outer function. Really that means that the outer function defines the inner function but makes that inner function callable to code outside of both of those functions. And that's exactly what we see here. So outer function has an inner function, and you'll notice that within the inner function we're referring to the outer variable here, which is global. That's similar to the one we saw in the previous example, but we're also referring to this inner value, and this is where it gets tricky to understand. So this inner function is referring to a local variable of the outer function. What actually happens is a copy of that inner value containing the text ninja, that's actually closed over, which really means that the runtime environment takes that and packages it up, makes a copy of it, and attaches it as extra baggage that goes along with this inner function. Remember, in JavaScript, functions are objects. So it actually adds that as an additional piece of information that goes along with that inner function, so that when we take that inner function and we assign it to this global variable named later, we can then invoke that inner function by way of that global variable later. And so when we do that, this is actually a function call operator here. It's literally going to call into this inner function. The curious thing is that we're calling into the inner function after the call to the outer function has completed and returned. So we complete this, we return from it. At the end of calling that outer function, later has been initialized to refer to the inner function, and so we invoke that inner function here. Now here's the tricky point. Because the outer function has already returned, you would think that the local variable contained within that outer function would have been blown away at this point. It should really, by rights, it should not actually exist anymore. But because of this closing over kind of an effect, we get a copy of that and it goes along for the ride. And so that means that when we call on later, it executes this code here, and it is actually able to access this inner value. Now, it's not actually the original, it's a copy of it, which is interesting. This code example doesn't really demonstrate this either, but it's interesting because you can actually have multiple closures that are separate from one another, and they have essentially become independent objects that contain data that go along with them as extra baggage, as I say, sort of going along for the ride. Now, it may not be that clear from this very simple example how this could actually be useful, but it turns out that this is extremely useful and pretty much the only way that JavaScript provides us with a mechanism that can simulate traditional object-oriented objects that contain data that continue to exist outside of the function that created them. So, but at least this example does give us a nice simple little mechanical example where we can kind of follow through it and see how it works, and we can see that this inner value persists outside of the function that had created it and made it available to external code, as we see down here. So it's a tricky point. Try going through it a few times on your own to get a clear understanding of it. Section 4, JavaScript Performance Analysis. It is often important to be able to analyze execution performance of JavaScript functions. This is the first step in any effort that relates to improving performance of your JavaScript code. We'll take a look at measuring elapsed execution time. We'll take a look at the getTime function as well as the time and timeEnd functions. And we'll talk about the importance of how to focus on performance bottlenecks in your code. In this demonstration, we're going to take a look at a code example where we calculate the performance of the execution of a piece of code to determine how fast it is or how performant it is. And so this is an example that's taken from a code snippet that appears towards the end of the first chapter in this book titled Secrets of the JavaScript Ninja. And this is a book that's published by Manning.com in their vBook library. In any case, let's take a look at this book, and as we can see here, we have chapter 1. Towards the end here, there's a section called Current Best Practices. And it talks about 3 aspects of best practices. So what they're trying to get at here is when you're creating JavaScript code, particularly if you're creating JavaScript libraries, anything of any significant size, you're probably going to want to focus on at least three important aspects of this. One is you have to get really good at testing thoroughly. Another one is you have to get really good at doing performance analysis, because quite often when you implement code, you have to verify that it's performant, and if it isn't, you need to be able to analyze it to figure out where the bottlenecks are, and then you have to figure out how to get in there and improve those performance problems. And then the third skill, which is quite important, is becoming a very effective debugger. So you want to get your debugging skills up. So it talks a little bit about these things. It doesn't give a whole lot of detail on these, but for example, in the current best practices under testing, they're recommending using this assert function, and you can check that out in the documentation. It takes 2 parameters. A parameter which is a Boolean, which is a condition. Another one is a message that is conditionally displayed depending on whether or not that condition evaluates to true or not. So that's actually something you've probably seen in other programming languages. The assert statement is quite commonly used in, for example, C# programming and so on. But this is what we're interested in this demonstration here, the performance analysis. And so, to be honest with you, this tiny little code example is pretty minimalistic. It's a little bit of a contrived example. I wouldn't say that it necessarily gives all that much of a real-world kind of an example of what's really involved in actual performance testing, but it's a start. It's the first chapter in the book, and so they're giving us some basic concept background. Of course, in real life, there's a lot of things, and I'll try to take a few moments later to talk about some of the things that would go beyond this simple example. But basically what they have us doing here is we have a variable called start, and it's assigned the result of calling on the getTime method on a new date object. And that gives you a certain number of milliseconds since a particular point in time where time started. And I'll talk a bit more about the specifics of that. It doesn't really so much matter when that is, but what is important is the difference between one point in time and another. So it's not absolute time that we're interested in here. We get the start time here, and then later we calculate the elapsed time by taking the difference between what it is now and what it was before we started this for loop. And so that gives us an estimate of how long it takes to execute that code. And I say it's an estimate because this date object and this getTime method are not really all that accurate. In fact, I probably wouldn't recommend using this specific example code that you're using here. As I say, this is a simplified example. In real life, you'd probably want to use something a little more accurate. And I'll talk a bit about what that could be, for example, in just a moment. But there's one thing you notice here. We have a for loop, and it looks like we iterate this for loop some number of times equal to max count. Now, we don't see what max count is. This would have to be something that would have to be assigned before we got to this point, and it would be some number. It doesn't really matter so much exactly what it is. It could be 100, could be 1,000, or something like that. But what we'd really want to do is take this elapsed time and divide it by that max count, and that would give us an approximate average value for an individual iteration of this function, and that would tell you how long it took to perform this operation that we're interested in measuring. Now, this code example doesn't actually do that. What I would recommend you actually do, though, is to take that number elapsed and divide it by max count, and that's going to give you what you're actually interested in probably measuring here. Anyways, it talks about some of this down here. It says, note that we perform the code multiple times. In this example, we perform it the number of times represented by max count. Because a single operation of the code happens much too quickly to measure reliably, so we need to perform the code many times to get a measurable value. So actually there's a couple of things. One is, as they're saying here, it would probably be so small that it would actually probably even be 0, because it's going to be rounded to the nearest millisecond, which is a pretty rough estimate. And the other thing is you might want to do an average over the long term, because there can be effects from caching and things like that that come into play as well. It's pretty tricky to really do this sort of thing in a really proper way, and this is a bit of a toy example, but it's a nice introduction to the concept. Anyways, let's put that away, because I want to open up, and I'm just going to open up in Notepad. If you want to open it up in some other kind of editor like brackets.io or Visual Studio Code or something like that, that's fine, but Notepad ought to do for our needs here. So here we have an HTML file that contains a script tag, and within that we have a function called getSum of first n primes. Takes a parameter n, which is a number. Nested within that function we have an inner function which is used to calculate a true or false value. It's called isPrime. So you can pass in a number to it and it will return a true or false depending on whether it's a prime number. And of course a prime number has to be 2 or greater. And if it is divisible by any number other than 1n itself, that's what's used to determine whether it's a prime number. So a prime number is only divisible by 1n itself and no other factor. Otherwise, it would return false. So that's pretty straightforward how that works. And we call that nested function from down here. And we're doing that from within a for loop. And the logic of this is pretty simple and straightforward, but basically what we're doing here is we're calculating the sum of all the first n prime numbers, where n is this parameter that's passed in. And it's not all that interesting a function really, but if you wanted to uncomment this and run this, you would see each of the first n prime numbers being displayed. We don't really want to see that probably, but that was just for testing purposes. I wanted to verify that it's actually producing the correct sequence of prime numbers up to n, whatever n is. But I'm accumulating a sum of all those prime numbers, and when it's all done I return the sum of the first n prime numbers, where that n is this parameter that was passed in. So this is where I'm calling it from down here, and I put a little console log here with some asterisks because I wanted to visually distinguish in the console output with the F12 tools within the browser. I want to see this output, and I want to see these two slightly different ways of doing the same thing. So basically this code here is pretty much identical to the code that we saw in the book, we're using the dateTime object getTime, and we iterate over some number of iterations. So my number of iterations here is this variable 100. Test count is 100. I call this lengthy operation here, get sum of first n primes. So it's going to get the first 100 primes, add them up, return the result. And then I'm going to do console log to display that. And then I do the elapsed time, and I get the difference, and then I display the elapsed time, and that's going to be in milliseconds. If you check the documentation on that, it'll tell you that the units are in milliseconds. So that's fine, but if I did this for a very small test count, let's say 1, you would actually see that this produces a value of 0, which is not really all that useful. But so it's highly recommended, and if this is the kind of thing you should probably do on your own. If you see somebody doing something a certain way, and you have a hunch that maybe there's a better, you're hoping that there's maybe a better way of doing it, probably you should get into do a Google search, or maybe check on Stack Overflow or someplace like that. You'll find Stack Overflow articles that talk about this. They'll recommend not to use this date get time. Many people will say that they recommend instead using this console time function and the time end, which is much more precise. And so you just basically call this function here time with a string that identifies the name of the timer. It's an arbitrary name. And then later you call time end, and it will actually display the time very accurately. So if we go ahead and open this in Google Chrome, and let's hit the F12 key just so that we can see the result of that. And so here we see the numbers coming out. So this first one says it was 13 milliseconds, and this more accurate one says it's 11.428 milliseconds. I would not go with the 13 milliseconds. That's probably not very accurate. And to be honest with you, that first approach is not very consistent. It depends on things like how timing is implemented within the virtual machine or the JavaScript interpreter. It's dependent on the platform that it's running on, the operating system, the granularity of the time-based system that it's based on, and so on. So I would not recommend using that. But just a quick few additional points here. Note that this example is a gross simplification. Even with my improvement on it, it's still a gross simplification. And it might be rather problematic due to things like code caching effects and other performance-related optimizations within the browser and so on, the JavaScript interpreter and the runtime environment. Also note that there are many other potential confounding factors when it comes to performance analysis in general. So for example, you often need to use specialized tools in detecting where the performance-related issues are of greatest concern, and then you focus on improving performance in only those areas where there is the greatest potential for improvement. Otherwise, you could waste a lot of time chasing down all kinds of things that are not really all that significant. So you want to use your time wisely. And there are tools that can help you do that. So also you need to do performance testing with a proper specialized set of tools that allow the code to be tested in realistic runtime environments. So this example that we looked at is obviously a very contrived example, and it's greatly simplified for demonstration purposes. Everything is entirely synchronous. There's no asynchronous things going on, for example, no calls into web services and so on. So there are many other factors to consider when analyzing your code for performance-related characteristics, and these are things like browser-related performance differences. Not all browsers are optimized in the same areas to the same extent. Required JavaScript libraries and frameworks being used can have an effect on performance. Synchronous versus asynchronous scenarios. Quite often you can improve perceived performance by doing things asynchronously. Performance effects of calling remote web services, including bandwidth and latency effects. Taking advantage of web workers and taking advantage of concurrency and multitasking in modern HTML5 based browsers could be a big improvement in performance. The amount of memory, network bandwidth, and the number of CPU cores, etc., these can all have an effect on performance. And also taking advantage of improvements in libraries. So you can get quite a substantial gain in performance just by going from Angular 1 to Angular 2, for example. Huge improvements. And also architecting your code to use functional reactive programming techniques as opposed to traditional object-oriented programming techniques. And so that in itself could be could be probably a 400 or 500 page book just on that one topic to learn how to do that properly. That's a very important up and coming approach that can quite often really improve performance, and it's really great for taking advantage of multi-core and that kind of thing as well. So anyways, that brings us to the end of this demonstration on performance analysis.